Although it doesn't often happen in math, sometimes things are really easier than they seem. If I gave you this equation, 4z squared equals 9, and asked you to solve it, find the numbers I can plug in for z that make the left-hand side of the equation, 4z squared, be equal to 9, what might you do? Well, the first thing you might do is to get the squared thing, that is z squared, by itself. So you might divide both sides of the equation by 4. Now you have something squared equals a plain old number. This is a great position to be in, because what we can do next is simply take the square root of both sides of the equation. Remember, squaring and square roots are inverse operations. They undo each other. So the square root of z squared is just plain old z. And on the right-hand side, the square root of 9 over 4, we can use the things we learned in Chapter 8 to solve that. On the left-hand side, then, we'll have z, and on the right-hand side, the square root of 9 on top, that's 3. The square root of 4 on the bottom, that's 2. And when you think about it, there are 2 square roots of 9/4. There's positive 3/2 and negative 3/2. So there are 2 solutions, 2 numbers I can plug into the original equation for z to make 4z squared be equal to 9. Those 2 solutions are positive 3/2 and negative 3/2. It's a reasonable question to ask, well, if it's so easy, why can't I always just take the square root of both sides? Here's 2 equations, and one of them is a very good candidate for taking the square root of both sides, and the other one isn't. Let's work through these and notice what's different about them. We'll start with the one on the left-hand side. In this case, I can first subtract 4 from both sides, and I get x squared equals 10. In this case, I have something squared equals a plain old number. X squared equals 10 in this case. I can take the square root of both sides to find out that x has to be plus or minus the square root of 10. Either the positive square root of 10 or the negative square root of 10 will work when you put it in the equation above. Now let's try and repeat this process with the equation on the right. In this case, I'll subtract 4x from both sides, and I'll get x squared equals 14 minus 4x. The problem here is that what's on the right-hand side isn't a plain old number. It's a number minus a variable. So we have x squared equals 14 minus 4x. We can't simply take the square root of both sides of this one because there's still an x on the right-hand side. And there's no nice, neat way to take the square root of 14 minus 4x without knowing what x is. So in general, if you can get an equation to the point where on the left-hand side you have some quantity squared is equal to a number, not a combination of numbers and variables, that's a good time to take the square root of both sides. Let's work through an example problem. The equation says solve 6 times the quantity x minus 4 squared equals 42. Well, in this case, the first thing that I'm going to do is I'm going to write the original equation and then divide both sides by 6. When I do that, I notice that I have something squared. In this case, the something that's being squared is x minus 4 equals a number. Something squared equals a number. X minus 4 squared equals 7. Now I can take the square root of both sides, and then notice on the left-hand side, square rooting and squaring, these inverse operations undo each other, so all I'm left with is x minus 4. And on the right-hand side, I need both the positive and negative square roots of 7. Now to get x by itself, I add 4 to both sides. And when I do that, I have x equals, and then on the right-hand side, either 4 plus the square root of 7 or 4 minus the square root of 7. So the solutions, 4 plus the square root of 7, which is approximately 6.65 if you do it on your calculator, and 4 minus the square root of 7. That's approximately 1.35. So if I plug in 6.65 into the original equation, the left-hand side will approximately equal 42. If I plug in 1.35 into the original equation above, the left-hand side will be approximately equal to 42 as well. These are the solutions to the equation that's shown above. We found them by getting our equation into a form something squared equals some plain old number, and then taking the square root of both sides. This is the end of this section. I know that it seems short and sweet, but this is a good time to take a look at some of the practice problems and see what questions you'd like to go over in class next time.